On the one hand, industrial operations in a plant require meticulous coordination and accuracy. On the other hand, automation engineers look forward to using a control system that reduces overhead expenses, streamlines operations, and mitigates system errors. That's why in today's world, most industrial enterprises rely on a supervisory control and data acquisition, known as a SCADA system. So let us start exploring SCADA. SCADA is made up of both software and hardware elements to create a control system used for industrial automation. It is a centralized system that allows you to keep an eye on a variety of equipment that provides information about particular processes that have become complex for humans to manage. Now let us find out where SCADA systems are needed. First, where you need to visualize real-time data on connected equipment located across a plant. For example, a flow rate of a pipeline, or how much a control valve is open. Secondly, SCADA is required where you need a safe environment and want the measurement parameters to be within specific ranges to avoid harmful circumstances. Thirdly, where you want to supervise and control numerous industrial sites while you don't have sufficient personnel to cover them, SCADA is needed. And fourthly, SCADA is a suitable solution for remote operating capability, meaning if industrial sites are miles away from your control center, you can still have visibility and control over your processes. Now let us learn about SCADA architecture and the main components used in this type of control system. Level 0 includes field devices such as sensors that recognize operations inputs and actuators that control operations mechanisms. Level 1 includes field controllers such as remote terminal unit or RTU and programmable logic controller or PLC, which interact with sensors and actuators. These controllers require configuring and programming to carry out directives critical to plant processes. And Level 2 contains a control center, including a SCADA server alongside SQL database, mobile HMI, and supervisory computer. All of the data and events related to the SCADA system are stored in the SQL database for further use. If you are at home or on the road and are worried about process parameters, you can still access real-time data through mobile HMI. At last, we have the supervisory computer that is the core of the SCADA system. It has embedded HMI software that displays the whole plant processes graphically and also allows interaction with final control elements. Please note, a complicated SCADA system can also have other levels and components. Here we just mentioned the main ones that are existed in every SCADA control system. Now let us discuss the SCADA function in detail that can be divided into 4 categories. 1. Data acquisition. In the lower portion of the diagram, sensors act as measurement devices that gather information on processes and deliver it to field controllers. 2. Data communication. Field controllers process and convert acquired data into usable information that will be distributed to a system of connected devices, such as servers and HMIs. But how do we send all data to the control center? The answer is in 2 words: protocol and transport. We send data over one of the most common protocols in the SCADA world, such as DNP3, Modbus, and SMP, to name a few. And the data can be sent across a network link or over a wireless network. 3. Data presentation. Once the supervisory computer has collected all data, it graphically displays plant information as mimic diagrams. It allows the operator to access real-time data of plant processes input and output in an easy-to-understand format. The embedded HMI software can log and track measurement parameters and production performance over the long term, which enables the operator to use these historical data to create trends and get customized reports. This way, since the historical data is available, the operator can predict what will happen in the future with the help of the HMI. The HMI continuously checks to see if particular alarm conditions are met to detect whether an alarm event has happened. Following the detection of an alarm event, the SCADA system draws the operator's attention, for example, with a red flashing sign on a screen. The supervisory computer can also send notifications to your cell phone to inform you of what has gone wrong at remote sites. As you can see, this text message is clear and understandable and also includes time and date stamps. And 4. Control. There are 2 ways to issue control commands. First, it can be done manually. In this method, the operator views the predicament situation on the screen and figures out what's happening. Then the operator makes a control decision and acts upon it. The control command is sent down to the field controllers to be executed by the RTU or PLC to modify the status of the targeted actuator. Secondly, the control may be automatic. This way, if the program is designed to run automatically when an alarm condition occurs, the HMI software itself will take care of that. So the operator doesn't have to sit at his desk all day waiting for that alarm to go off. Finally, let us consider reviewing the most significant features of the SCADA system. Since the processing time in the SCADA system is almost fast, it is suitable for time-sensitive processes. The SCADA system's communications options are many and have evolved to keep up with new technologies. The embedded HMI software is not integrated with tag databases, so you must buy extra software to create or import your tags. If security is a priority, then the SCADA system is not a suggested solution because the SCADA system switches from proprietary technologies toward open alternatives. So the lack of sufficient security allows hackers to gain unauthorized access to the control system and send commands to SCADA field devices to corrupt the plant processes. The SCADA system can anticipate possible failures before they happen and send out immediate warnings to the responsible personnel to fix the issue before it causes serious problems. This way, the downtime of the system is mainly reduced. You can manage to control complicated systems with well-trained personnel of the SCADA Control Center. This way, you don't need to have a vast army of specialists since the trained personnel can handle different situations with the help of leverages provided by the HMI software. And sometimes multiple servers are arranged in a dual redundant configuration to enhance the system integrity. This way, if the primary server faces any breakdown or fault, the redundant server takes over and ensures continuous management and monitoring. What do you think of using SCADA as a control system? Please share your thoughts and experiences with us and the audience in the comment section. Also, please encourage us by liking the video, subscribing to our channel, and pressing the bell icon so you can get notifications whenever we publish new out-of-the-oven videos. This way, you keep motivating us to produce more informative videos.